Hello, everybody. I'm Radha Dasari from Web3 Foundation. I'm excited to give you a glimpse of development on Substrate using Frame. So let's get started with the presentation. All right, so as this is the beginner's track, I'll make absolutely no assumptions on what you know about Substrate. Let's start with the basics. So what is Substrate? It's a modular, flexible, and extensible framework for building blockchains. So Substrate is open source, and it is written in the Rust programming language, which supports a clean and easy to maintain modular design. Okay, so Substrate provides a full set of features and functionalities required to create and run a blockchain. So in today's workshop, you will get a hands-on experience on running your own instance of blockchain and customizing its runtime logic. The tasks in this workshop will highlight the modularity, flexibility, and extensibility features that I just introduced you to. All right, so let's go to the main topic of the workshop, which is Frame. Frame, it is the framework within Substrate for runtime aggregation of modularized entities. In simple words, you as a developer will have access to multiple modules, which we call pallets, that are ready to be used to support your runtime logic. For instance, let's say you're trying to build a blockchain with its native currency. You would need that to have support functionalities pertaining to accounts and balances, balance transfers, etc. So to be able to do that, all you have to do is import a pallet called as balances pallet, provided through Frame. If you'd like to include some kind of democracy in the way you govern the blockchain, there is a democracy pallet. For staking, you have a staking pallet, etc. So you get the idea. Later in this workshop, we'll have a hands-on experience on what it takes to include a pallet into the runtime of blockchain. So Substrate by design allows you to modify or replace the pallets to suit your needs. So we will get back to this slide again, like I promised, at the end of the session. By then, you'll have a full understanding of what this technical freedom and development ease means. So Substrate repository, it ships with a node template that will get you started instantly with developing with a basic and functional blockchain. So you can use the Frame pallets to customize the blockchain's runtime. And if the existing pallets available do not meet your requirements, you have an option to even modify the Substrate core primitives, which is the extreme right end of that particular spectrum. Okay, so if you attended the Sub0 sessions yesterday in the Substrate ecosystem, the big picture talk, you would have heard that there are over 300 pallets at your disposal as a developer, and the list is growing very rapidly. So over 50 of these pallets are available through Frame, so you can go to the GitHub repository and see them for yourself. So basically, if you look at developing on Substrate using Frame, it more or less looks like you're building a structure using Lego blocks. Okay, so you can pick and choose what pallets you need in your runtime, and put them all together to work in harmony and have like a fully functional blockchain. Okay, so without further ado, because this is a workshop, it involves some hands-on activities. So I'm gonna briefly talk about the workshop agenda, and we can get right into the tasks that we have planned for today. So the first thing is you'll be dealing with a node, okay, a blockchain node. So it's important for you to understand its anatomy. Okay, so that'll be the first part. The next part is about the node itself. So what did Substrate developers provide to you with the template node? So we're going to take a look at that code briefly, and I'm going to walk you over like a Substrate palette, the source code of a Substrate palette, and finally, talk about innovating with Frame, which is the theme of this workshop. So anatomy of a Substrate node. So a blockchain. Okay, so what is blockchain? Where does it exist? So unlike in Web 2, everything is centralized. You have services and data. You have it on a centralized server. unlike that, like blockchain lives among the nodes in the network, right? So it more or less lives and functions on nodes. So it's important that all of these nodes in the blockchain network communicate with each other reliably. For that, Substrate uses lib peer-to-peer, modular network stack. If you heard of like IPFS, which is the file system that powers the distributed web, the same developers, created lib peer-to-peer network stack too. And also, Substrate's vision has always been futuristic. The developers of Substrate picked WebAssembly, which is also known as WASM, which allows efficient execution of the blockchain runtime code. So there is a workshop actually happening parallelly to us in the intermediate workshop stage. They're talking about light clients. So the very possibility of light clients, light nodes running on a browser is made possible by WASM. The other important thing about blockchain is all the nodes have to agree that some chain is canonical, right? So there is this concept of finality and consensus. So Substrate template node ships with the finality gadget called as Grandpa. So this was developed by Web3 Foundation researchers. So I'm actually in that office right now with them. So they've developed this, and this is available for you to just plug and play. Okay, so you have these nodes, you can deploy them. All of them are going to talk to each other and agree on a canonical change using this Grandpa palette. And this code was developed by Parity, by the way. All right, so let me also go over a little bit about how things work inside a Substrate node. As an end user, you connect to the blockchain nodes through an RPC server, right? So if you open Polkadot, you're through Polkadot.js, you're actually connecting to a node. So this is going to interact with their runtime, and also the transaction pool up there. It contains all the transactions, whether signed or unsigned, that are broadcasted to the network and that have been received and validated by the local node. So all of these transactions are added to the pool and are communicated with other nodes in the network through lib peer-to-peer. So through the consensus, the node will get to know about the finalized blocks. The executor is right at the heart of all of this, process. The runtime is like a WASM blob that contains the chain state and its transition logic. So if you heard about forkless upgrades in Polkadot, it's basically this. So the entire chain state transition logic can be updated on the fly, and from then on, that is going to take care of all the things that are executed in the node. And I want to highlight this finally, the node metrics about the node that you're running. They can be viewed via telemetry. So I request moderators to post the Polkadot telemetry website link. It'll be interesting to see all the nodes across the globe that are working in harmony with each other to keep the blockchain network alive. All right, so let's get to some action. The Substrate template node, it's a basic chain with administrative governance. It's just you, and you have full authority to do anything with that blockchain. So it'll be a good starting point for beginners like you to get started with development on Substrate. And to make your life easy, Parity has created a playground, okay, with several templates. The link for Substrate Playground is available in the slide below, and it's also available in the link shared earlier by Sacha. One thing, we haven't tested Substrate Playground at this scale. So if the Substrate Playground breaks due to load balancing, so don't worry about it. Just follow what I'm demonstrating in this talk. To make everybody's life easy and have an optimal learner experience, I already have the video pre-recorded. So let me get started with the video demo. So shortly, you'll see the video. Okay, so I hope you are able to, finish the sign up. If you don't have a GitHub account, I request you to, do that. By default, it's going to run that command. The moment you open the Substrate node, it's just going to, we're going to use the node template, by the way. Okay, so there are a bunch of templates there. The node template is the one that we'll be using for the workshop. So the moment we click on it, let's see what happens. So by default, the same command that I showed earlier got executed. And now you see a blockchain in action already. So you see, the authority, who it is, and then you have a node ID associated with the, the node that's running. So you have hashes that are generated right there. And yeah, so all of these are like pre-sealed blocks. They keep adding to the blockchain that we just started. And you can go to Playground and open Polkadot.js apps. So this is one way to see what's happening with the blockchain in a better way. So as a developer, you'll be using Polkadot.js a lot. So you see the custom endpoint right there. So that is where we're connected to. So if you are following this workshop along with me, you'll have your own unique URL, which is pointing to the workspace that you're working on. So as you can see, the block numbers match with what's happening in the command prompt right there. Let me go to the change state. And in here, in the storage, you can see all of these, pallets that are exposing like storage items for you to examine through Polkadot.js apps. So you have balances, pseudo, system, and there is the template module. I'll show you briefly like where that pallet is. And yeah, so our target is to add a new pallet. Okay, so from frame, so that we'll be able to access it through Polkadot.js front end that I've just shown. Okay, so I'm going to briefly go over, because I talked about the anatomy of a node. So I'm going to show exactly where you can find that code. Okay, so this is the entire code that's creating that blockchain that you're seeing in the command prompt. So the chain spec. So the chain spec is an interesting file altogether. It's going to contain the consensus critical Genesis configuration. Okay, so it contains all the starter functions that let you create account keys from the seed. It is also the job of chain spec to configure the storage values that the chain needs at the use, when the chain is starting from Genesis. As you can see, if you examine that code, you'll see keys for Alice, Bob, and others. All of those accounts are going to be created, pre-funded at the beginning of the, at the beginning of the chain. The other important file is RPC. So here you have an option to add custom RPC calls. So that's going to be very useful. You can extend the functionality that is already out there. And the next big file you can see right there is service. So this is almost like a service factory. It's going to contain things about client API, consensus, finality, key store, telemetry, etc. So I'm going to stop the execution. I request you to press Control-C as well. So we're going to stop the execution of this blockchain. So what I'm going to do is, so that's the template that I talked about. If you're building a brand new pallet, you'll include the code right there. But for now, we are not writing any code. So we are just using a pre-existing frame pallet in this runtime. So in runtime, this cargo toml file is the one that contains, dependencies. So here you can see balances, and then there you can see grandpa. But just by including that in this cargo toml file, you're able to import all of them. So cargo, it's just like a package and dependency manager, like if you're familiar with other programming languages. So it's the counterpart in Rust. All right, so yeah, so here you list all the standard libraries features from individual pallets. You want them to be included in the runtime as well. So without further ado, I want to, so don't run this. It's going to take a lot of time right now. So I'm just going to demonstrate how a multi-chain blockchain works. Because what is the fun if you're just running a single node, creating a blockchain, right? So I'm going to use cargo clean. That is going to clean all the binaries that were already executed before. So here I'm going to execute this command. Okay, so what I have is I'm going to run a validator node with Alice keys, which are already present in the Genesis. So I'm going to copy that over and then paste it right there in the command prompt. And once again, like, don't run this. It's going to take a lot of time. So what I did was I fast forwarded this video just to show you like what exactly I mean when I'm running a multi-node blockchain. Let's see what's going on. As you can see, the node is being compiled from scratch, and you can see all the pallets that were added right there. And there you go. So the node is assigned with an ID. And again, if you observe closely down there, it's not producing any blocks, because in a multi-node blockchain, you need multiple nodes that talk to each other while creating the chain, right? So I'm going to create another validator node. So I'm going to copy over that code. Because I'm running it on the same machine, I'm going to change over some ports. Let me see what happens. There you go. So this node basically discovered the other node. We didn't have to tell it where to look for. It automatically discovered it. And both of them are working in conjunction to create a blockchain. There you go. So you have a functional multi-node blockchain. So when I stop this node, it stops producing blocks. So check out the tutorials on Substrate docs. It's going to show you how to deploy your own private network. Interesting stuff. All right, so now coming back to the key theme of this workshop, we're going to take a look at including a pallet into Substrate blockchain runtime. So this is the tutorial. I mean, there's a lot of content in here. I don't want you to get lost with all of this in this workshop. So that's why I brought the important stuff into the main document that I shared. So as you can see, to add a new pallet, you just have to change like 2 files, at least for this particular pallet. So one is cargo toml file. You add a dependency, and then in the runtime, you're going to add some code that implements the interface of that particular pallet. Okay, so go to the cargo.toml file in the Substrate node template code. I'm going to copy over that code. And yeah, I'll navigate to the runtime folder, go to cargo toml. At the end, I'm going to add that piece of code. Okay, so there you go. So I'm adding pallet next as a dependency. I'll just make sure the tag matches with whatever I have right there. Let me copy that over. Perfect. So by default, the default features are turned false, right? So the standard library, we don't want that to interfere with the standard library of the runtime itself. So we're going to include that separately. I'm going to show where you'll do that. So you have the standard libraries of all the pallets listed right there. I'm going to add the next pallet's standard library. I'm going to include it right there, and that's all. That's all you need to do to include a pallet as a dependency in cargo toml file. So I'll run that command just to make sure that everything works. So I've added like a new pallet to my runtime. I'm just going to make sure that all the dependencies are taken care of and everything works smoothly. So if everything works smoothly, you'll see this execution happen successfully. So you'll arrive at that. We're going to switch to the next important thing. The tutorial itself is going to talk about the source code of Nix pallet, like what it is, make a comparison with the balances palette, which is already available. I highly recommend that you go over this document later. Yeah. So what we're going to do is, as you can see right there, there are a bunch of constants that we gave right there. So we'll come back to this when we are testing this palette. Okay, so there's a minimum length that is required for you to give a nickname to the account. Let's go to that lib.rs file, which is the most important file in runtime, and add this block of code right below, like the balances palette. Okay, so I'm just going to place it right there, find it. Yeah, so basically this has the implementation of all the interfaces that we defined earlier. I'm going to paste that code right there. There you go. So now I have the parameter types and an implementation for that particular palette. So the next step is to be able to compose the runtime. So right now, already all the palettes are working in harmony. Now, because we added like a new palette to our runtime, we want to construct our runtime with all right, so yes. Sorry about that technical glitch. I hope I'm live now. Okay, so what I did there was I just added the line of code to construct runtime. And now when I save this and then when I execute this, I should be able to see that everything is working smoothly. So what I'm going to do is I'm going to build this in as a release. So I'll execute that command. And again, so this is going to make sure that the palette runtime is included in. So the next palette is included in the runtime. Okay, so I'm going to run this node in the development mode. Let me go back and then copy over this command. So in the workshop document, I've even given an extra argument that you have to send to be able to check what's going on in the node using the Polka.js. So I'm going to add WS external. So basically, you're enabling the WebSocket to connect with external entities. So let me go to Playground and then open Polka.js apps. So here, I'll go to developer and then change state. So as you can see, you should have like next palette listed right there. And yeah, as a developer, you can also give some extrinsics to the chain. So what I'm going to do is I'll select the next palette. I'll set a name to the account on chain. Okay, so let me give my name right there, Radha. And you saw earlier that the minimum number of characters that are required are 8. So obviously this is going to fail. Okay, so that's what it's saying. So the runtime kicked into action and then it gave this error. So I'm going to increase that to my full name and then try to submit it. Perfect. So now Alice is named as Radhakrishna on chain. Okay, so you can play around with this whole next palette and see what you can do. So there are lots of functionalities that are displayed in there. So here so you can also see that all of them are pre-funded with some account balance, and feel free to check all the features that are available for you as a developer right there. And the next important thing that I want to talk about is, so far you have seen simply, adding a particular palette to frame. If you want to create your own palette, like a custom palette to do something interesting, then you have to do it differently. So there's a tutorial for you in the docs. It's called Substrate Kitties. What's interesting about this is you can have kitties created through a particular palette. So there are more files that you have to modify when you're trying to create this one. Okay, so I'm gonna get back to the presentation and then conclude this workshop. Okay, so what we saw, I'm just going to summarize like what we did. So there was already an existing, palette in frame available for you to use. You just brought it to the runtime and then, you've used it. Pretty simple. But to create a brand new palette, okay, so to do that, you should understand like how to write code in Substrate. So basically, it not only involves proficiency with Rust, it also requires you to understand how macros work in Substrate. Okay, so macros are pieces of code that write code for you. So in this skeleton palette code that I listed right there, you can see that are, so different kinds of macros defined there. First, you start with the imports and dependencies, then you create a placeholder to implement traits and methods and declare the palette type. So when I say trait, think of it as an interface in other programming languages. Okay, so all types of constants in the runtime would go in there. The next important thing is runtime storage. So the next talk in this beginner's stage is going to be on runtime. So I hope you watch that as well and learn more about how data is stored on Substrate. And then we have events, hooks, and calls. Feel free to explore about them. So calls are any functions that you invoke from an external origin. All right, so I'm going to briefly talk about the balances module. So the balances module, this is included in Frame. It defines like cryptocurrency capabilities for your blockchain. And more specifically, it lets you have like storage items that keeps track of the tokens the user owns, functions that users can call to transfer and manage these tokens, APIs which allow other palettes to make use of those tokens, and hooks which allow other palettes to trigger function calls when users' balance changes. A lot of interesting stuff if you dig deeper into how palettes work. And yeah, so the theme of today's workshop. So I apologize for the technical glitch in between, but anyways, I hope you took home the message that you can innovate with Frame. Okay, so right from the 0th level I show there, which are primitives, aptly named as Substrate primitives. SP stands for Substrate primitives, SC stands for Substrate clients, and then you have Frame, which are more user-friendly and which are like Lego blocks. And then finally, palettes, which are like boxes, okay? So which you can develop, and then you should be able to deploy them, make them available for others to use. For instance, like if you're interested in NFTs, Substrate has this unique palette that you can import and use. So all of this is open source. You can go to those libraries, add more code, modify it, make it more efficient, and so on and so forth. And yeah, like I promised, I'm showing this slide again. Start with the Substrate node. It's as a beginner, that's where you enter the Substrate ecosystem, play around with it, try to understand the capabilities of the palettes existing in Frame. And then if you're interested further, delve into the Substrate core, the primitives of Substrate, where you have an option to change like the consensus mechanism. Say, so if you're not happy with grandpa that we came up with, you can have your own consensus mechanism. And with that, I'm gonna conclude today's workshop, and I'll be there in the Discord chat server as well. I'm gonna answer all the questions you may have come across during the workshop. But yeah, so I hope you innovate with Frame. Thank you. Hey, Sachan.
Hey, Radha, can you see me? Cool, thank you so much. That was super cool. And I think even with a technical glitch, it was probably a good thing because a lot of people are compiling their nodes and that takes a while too. So, I mean, on that note, I really hope that right? I really hope that some of you like actually followed, and if you didn't get the chance to follow during the workshop, just go back, to that link that Red had. Like, by the way, great link, great idea. I think you used Docusaurus, super neat. It looks great, and I think that it'll help people follow, right? So we have a couple questions, and we do have time for them. So let's take our time, to answer these questions. Reda, I'll be reading the questions from the question bank. I've kind of picked a few already, and the first one I want to start with is a question by a username The Oyster, who is asking, like, if you have zero coding experience, but you want to learn how to code with Substrate, what do you do? Where do you go? What would you recommend folks out there do?
Honestly, for me, so I have the experience of teaching like computer science courses. I've taught like Python, for freshmen in the universities. So for me, it took some time to pick up like Rust. So the best resource for Rust is that Rust book that is available for free. Anybody can start it and learn things from it. So that would be a starting point. When you get to the 10th chapter of that book, that's enough. You can switch to Substrate and then start making connections. Okay, so this is what the developers created in Substrate, and this is using that concept. So you'll be able to make those connections and start learning from it. And I also mentioned that Substrate is more than Rust, right? So there are macros involved. So it's also important for you to understand the core concepts of how Substrate is designed. So it involves a little bit of learning curve, and I hope the new Substrate docs are amazing. So I would go there and then start going through all the tutorials, and that would bring you up to speed pretty quickly.
Yeah, I think that's a great answer. In general, I think there's people feel that they're kind of stuck because they don't know Rust. Well, I always would recommend to learn Rust while you're learning Substrate in parallel. For sure, there's some really important key primitives and concepts that the Rust programming language offers and that we leverage in Substrate. But like you said, Substrate really is its own thing. And especially when you're building with things like Frame, where it's all macros and it gives you these capabilities that is very unique to Substrate, right? So yeah, for sure. And look at the docs. Thanks for that, by the way. We just, so the docs team just released our new documentation site, and it's been a long time coming. So yeah, just immerse yourself there. That's a great place to start for sure.
Right.
We have a couple more minutes, I think. So, oh yeah, this is an interesting one. And it because it comes up a lot, and I think it's interesting to touch on it. So Mahesh is asking, can you explain what no STD and the STD features are in Substrate when you're building when you're building with Substrate?
Yeah.
So that's compiling to WASM and things like that, right?
Yeah. So no STD. So you don't want to miss. How would I put it? So there are this standard features that the main runtime has, and you don't want to interfere with that, right? So you put that no STD thing at the top. That is the first thing that you'll see in that lib.rs file right there. So that is to. So you're saying no STD, and then you're including all the standard features of these individual pallets like separately. So in the cargo.toml file, so you have that STD features thing where you're specifying the standard features that you would need in the runtime from individual pallets. That is what I would see with that. But I can definitely give a better answer later in the chat or the Discord server.
Yeah, it's a pretty packed topic, I suppose, because it touches on the capabilities with WASM and why we would use these certain features and stuff. But yeah, definitely, guys. We're here, so you can chat to us in the Discord chats, and we're happy to take more questions. There was one question about. Sorry, guys, just scrolling through these questions here. Oh yeah, about reading Rust docs. So the question is, what's the best way to read Rust docs and learn from the Rust docs? Maybe we can
So
start with
I
answering like what are Rust docs like, and why are they helpful? I know you
yeah
know this one because
yeah, of course. Like so when working with you, Sacha, like I had to like do this parallelly. I think the book was like a very good resource for me because I was able to go back and forth. So the the Rust book itself was like very resourceful for me. So
it's
you
it's all
definitely
this
need.
it's all the documentation of the source code, right? So it's really the place to go when you want to understand what are all these traits doing, what are these types, what are these APIs, right?
And you have a similar thing in the Substrate too, like Substrate docs, if I'm not mistaken. So that totally gives you exactly what each thing is doing. Give like proper developer level documentation, which is what is abstracted out in the Rust book. Okay, so in the Rust book you have a conversational style where you're explaining stuff. But Rust docs are more of so once you're comfortable being a developer, you can just go to them and then understand at the core like what each piece of code is doing.
Yeah, for sure. Yeah, and to add to that, like, I mean, Substrate is open source. You can just go in the repo and discover all of these cutting edge capabilities that aren't necessarily published in production, right? And I encourage you to mosey around because it's a lot of fun, right? You're seeing the things being created as they're being created. Um,
Right.
so the Rust docs really is like learning from the source code, but with the Substrate documentation team, like we kind of have like an easier entry point. So if you go to docs.substrate.io, you will find the concepts that we're bringing forward in the source code with Substrate. And then, after doing some tutorials and stuff, you'll quickly be immersed into the Rust docs, where you're going to need to know what this certain trait does in order to use it in your runtime. And so kind of I would describe it as sort of different layers of depth as you progress in your journey of being a developer with Substrate. Super cool. So I guess I have like an overarching question, which is like I'm very passionate about the way that building runtimes kind of forces us to change our perspectives on application specific blockchains, and really on our perspectives on like the things, applications we can build in Web3, right? And so my question is, how would you describe building a blockchain with pallets? How would you describe that being sort of like a new way to innovate, really?
Yeah, I mean, this is a great resource. I mean, if you because you registered for this track, I'm gonna say that all of you are beginners, and if you'd like to enter the blockchain space, I can't find a better resource than what we have right now with Substrate. Here, you don't have to worry about consensus or other extra layers that you require to run a blockchain node. So you have everything prepackaged, and you can only focus on the application logic, right? So think about all the parachains that are going live on Polkadot and Kusama. So what are they doing? So they're using the Substrate-based code mostly, and then they're adding this runtime logic, which is giving, opening up the space to a lot of other applications, right? So think about somebody trying to do something with real world assets like centrifuge, for instance. Okay, so they don't have to worry about the blockchain in itself. So they had to figure out how to connect real world assets with some identifier on blockchain, and that became like an application in itself. So if you have interesting ideas and applications, and you want to build that on a blockchain, this is where you start. I mean, I can't think of any other ecosystem right now to go to. If I had an idea, I would definitely get started right here.
Radha, those are great words to end your workshop and your presentation.